Welcome to solverfy.
In this problem, we have some string with a washer on it, and the washer is going down the string with a speed of 28 meters per second and an acceleration of 7 meters per second squared. We know the x, y, and z dimensions of the end of the string, and we want to find the velocity and acceleration of the washer in terms of cylindrical coordinates. So, first thing to note about this washer is it is going down a straight string. So, what this tells us is that the angle that it has is not changing at all, and therefore it's not accelerating either. So, what's convenient then is that we can essentially remove all of the components of these two that contain a theta dot or a theta dot dot. So that's gone, that's gone, that's gone, and that's gone. Next, we just need to find what r dot and z dot are. So to find those, we'll first need to convert speed and acceleration into Cartesian coordinates and then convert the x and y components of that into r, and the z component will of course be the same. So for the finding the Cartesian coordinates, we know that there's going to be some unit vector A where the magnitude of it is the magnitude of our string. So that's just going to be the magnitude squared is going to be 2 squared plus 6 squared plus 3 squared. And we can multiply these out to get 4 plus 36 plus 9. And 4 plus 36 is 40 plus 9 is 49. And so we know that the magnitude of the string is just square root of 49, which is 7. So then our vector a hat, our unit vector a hat, is just going to be each little component divided by the magnitude, which is going to be for x, since that's 2, that's 2 over 7, y is 3, so that's 3 over 7, and z is 6, so that's 6 over 7. And the speed vector, which we'll call v, in Cartesian is just going to be our speed, which was 28 meters per second, so 28 times a hat meters per second. And our acceleration vector in Cartesian is similarly going to be 7 a hat meters per second. And so we can already find the z components of this. So z dot is just going to be 28 times 6 over 7. And similarly, z dot dot is just going to be our acceleration, 7 times 6 over 7. But to find the r component, we're going to have to do a bit more legwork. So first, we're going to have to find x dot and y dot, which are just going to be our components of the velocity times their corresponding, our overall speed, 28 times their corresponding components. So 28 times 2 over 7, 28 over 7 is 4, so that's 4 times 2, which is 8 meters per second. And y is 3 times 4, which is 12 meters per second. And we'll do the same thing for acceleration, which is going to be a little simpler since we have 7 and 7, so that's just going to be 2 meters per second. And y dot dot is going to be 3 meters per second. So to find r from these, we know that generally r is square root x squared plus y squared, and the same thing will apply here. So r dot squared is going to be 8 squared plus 12 squared, and r dot dot squared is going to be 2 squared plus 3 squared. We'll do this one first since it's a little simpler. So that's 4 plus 9, which gives us 13. So our dot dot is square root of 13. And our dot squared is 64 plus 144, which is just 208. So our dot is just square root of 208, which we could probably simplify, but we can do that later too. So we now have the r dot and r dot expressions and the z dot and z dot dot expressions. So v is then going to be r dot, which is square root 208 times ur plus 0 u theta plus 28 times 6 over 7 for z dot. So that's 4 times 6, which is 24. So that's 24 uz. Should be little hats. And a is going to be root 13 ur plus 0 u theta plus I believe this was 6 over 7 times 7, so that's 6 uz. And those are our solutions. If we wanted, we could plug square root of 208 into a calculator. That would be 208. So that's about 208, 14.2. And square root of 13 is about 3.6. So we could alternatively swap these in if we wanted a decimal answer. And remember, these u theta components are 0, so they don't really count. And that's the solution.